Morning, everybody. I'm going to show you the circuits that control the pickup coils to the caps. I've got two timers here. This one here is free running, in other words it's always on. It puts out 160 microseconds as the on time for the pulses. It's got 0.02 microfarad on the cap down here, a diode, 10K, another diode, and then it has a cap here that takes the output splits. It goes over to the driver chips, and then it also goes to through a 0.001 microfarad cap, 10K, into pin 2. This is basically another one shot that fires over and over and over, and that goes over here to a inverter, round through the inverter, through a delay, and then out. And what you get are the two pulses. The smaller pulse is the output, to dump the cap to another bank of caps or whatever, and that's in the middle of the fill pulse. And so this is a CD 4049 inverter, and then the other pulse generators are the NE55 timers. This is a comparator, an LM339. Pin 6 goes to a 5-volt reference. The pot ties to a 100K resistor. That goes to the high voltage cap that's being initially filled from the pickup coils, DC energy. You'll see that on the next page. The output from this is pulled high with a 10K, and then it goes out to the enable on the driver chip. So the drivers have to have an enable. I'm not using a 1 meg feedback resistor at all. It's just there because it was on the original schematic. Here I've got adjust this a little bit. Here I got the 3 pickup coil phases. Now they go through the bridge, through these separating diodes, combine into one piece of energy, which can either be this is set up for 100 volts. This 100K gets changed to 250K for the 300 volts. I'm going to try playing with this circuit with the ECM output, and then that goes over to this switch turns on repeatedly, and just constant running, and goes and fills these caps up. And there's the driver, the enable, and this driver is pulled high with a 10K. Free running pulses come in and fire. This is a P channel high voltage FET. And then down below here we've got same setup, P channel, dumping the positive voltage from this cap into this capacitor bank and then to the output. This particular driver has the dump output pulses that are in the center of these things when these are off. LM339 output sets the level that you're going to fill at. Whenever this reaches that level, it's going to dump that cap into these caps. And what I found out was when you set the level below like 105 down to 70 or 80 or 60, it does load the motor down. As soon as you adjust it up to the peak voltage of about 105, which means that the pulses going in on the power coils are peaked, that when you switch the circuitry on for this whole, I have it turned off. These caps are 0 volts, meaning the maximum load coming back from this will be used to fill this if there is a load. When I turn the power on to this board, bingo, not one bit of load back to the motor, and yet these caps and these caps fill to 105 volts with no load on the motor. What that means is you could have thousands of caps out here all charged to 105 volts. Millions of them, doesn't matter. It's not going to load down the motor because the pickup coils are wound around the power coils, and they duplicate basically the energy that's occurring minus 50 volts. and that's just the way it turns out, and the magnetic fields talking to each other. And but I did see the loading will occur on the motor if you turn the comparator down lower to lower voltages. The reason why is it's 152 volt pulses are going to the motor, so the magnetic field is expanding outward. It hasn't reached quite its peak yet. So as it's reaching its peak, that's the time that you want to pull the energy out, because you're in the dead top of the power pulse. And I guess you probably could use Konehead short. This is all Doug Konzen circuitry, basically. I've just modified it some, so I got it to work with my stuff. And so I need to test this with the power coil. The same exact circuitry. Take a power coil from not the power coil, but the ECM inputs to this, and then do the same concept. Next test. Anyway, looking good. And on the motor, let me show you that for a second. What I had to do, my plastic plates are cutting boards, and they have to stop the rubbing, because this thing isn't perfectly aligned, I had to pull on this back plate in this direction. And I tried using shims down at the bottom. That worked a little bit, but I ended up adding a piece of ready rod here that actually pulls this whole mechanism, so it keeps it nice and straight. I added these pieces of wood here to also help support it on both sides. So that's where we are right now with that. Since the circuit over here is working with that processes the pickup coils, it looks like a mess, but it works fine. Anyway, so this whole thing works. I've got all the part numbers, all the numbers on these schematics are accurate, and they'll give you the 160 microsecond pulses and the 50 microsecond pulse dead center when the free run is in the off position to dump. So anyway, have a good day.